Hello everyone, I am Himasati Sharma and student. We are discussing the chapter electric current and its effect. In our previous two lectures, we have studied what is electric current, how electric current flows in a circuit, how to draw a circuit diagram, what is closed circuit and what is open circuit, and how to combine cells to form battery in series and in parallel. So today we'll be discussing about heating effect of electric current. So electric current, basically whenever electric current flows, it has four effects. One is heating effect, magnetic effect, mechanical effect and chemical effect. So in this chapter we are going to study two effects of electric current, which is heating effect and magnetic effect. So whenever there is a flow of electric current in an electric device, if there is a production of heat, it is called heating effect of electric current. Production of heat in an electric device due to the flow of electric current is called the heating effect of electric current. Examples are electric heater, electric bulb or room heater. So when these appliances are switched on after connecting them to the electric supply, what happens? The elements of the appliances become red hot and release the heat. So this release of heat or this becoming red hot happens because of the heating effect of the electric current. So how much heat will be produced? The amount of heat produced in the element or in the wire will be depending upon the material. That means the kind of material it is, thickness and the length of the conductor. So if we say it depends upon the material, that means the material opposes the passage of current, which is called resistance. So basically the amount of heat produced in the wire depends on the resistance of the material, thickness of the wire and length of the wire. So when electric current passes through a high resistance wire, so if the material is such that it is creating high resistance, the electrical energy gets converted into heat energy. And this heat energy heats up the wire and causes the heating effect of electric current. So now we will be dealing with the factors on which the heating effect of the current depends. So there are two factors on which the heating effect of current depends. First is resistance of wire, that means kind of material it is. So greater the resistance of a wire, greater will be the heat produced in it by a given current. So if a current is given if a current is supplied and the resistance of wire is more, therefore it will produce more and more heat. Provided that, so now if you compare two wire, one has more resistance and one has less resistance. So let us take example of copper and nichrome metals. So one wire is of copper and other is of nichrome. Both the length of both the wires is same, thickness is same, and the amount of current which is passed through is same, and the current is passed for same duration. So every other factor has been kept constant. Only difference is the kind of material. So we will observe that nichrome wire will become hotter in comparison to the copper wire. Why is it so? Because nichrome wire has a good resistance or a better resistance than copper wire. So therefore nichrome wire is used in electronic devices or heating devices rather than using copper. Clear? Now the second is magnitude of current passed through a given wire. So if magnitude means how much current is passed. So if the magnitude of current passed through a given wire is greater, then the heat produced will also be greater. So if a normal amount of current flows through copper wires of household electric wiring, nothing will occur and it will not become much hot. But when a large current flows in the same wiring or accidentally, what will happen? The iron wires will become extremely hot or fire may also be started. So now what can happen if a large amount of electric current passes through such wires? So they will become hot, they can melt or they can break. So therefore now this thing can also be used as a benefit to us in some safety devices which we call fuses. So electric fuse, you must have heard that fuse, the bulb has been fused or the wiring is fused. So the heating effect of electric current utilized in a safety device which is called electric fuse. So let us study what is electric fuse. So fuse is a safety device which works on the heating effect of current and prevents electric fires or damage to electrical appliances due to excessive flow of current, and it is known as electrical fuse. So suppose that your electrical appliances or your electricity which is running in your house is 220 volt, and there is some appliance which and all the appliances, they require 220 volt or the electricity below it. But now what happens suddenly, because of some problem or some fault, the more voltage is being supplied to your house. So now what will happen, all the electric appliances will damage because they'll not be able to take so much greater voltage. So to prevent this, what can be done? So at your main switchboard, an electric fuse is provided. Now this fuse has a thin and short wire. So whenever more voltage is passed or more electric current is passed, this wire heats up and it melts, and when it melts it breaks down. So since it breaks down, now there is a circuit is not complete, that means circuit is open or circuit is broken. So now the current will not pass through to other devices, and this way it can prevent the damage to electrical appliances. So as I mentioned, the safety device which we call electric fuse consists of a short length of a thin wire which is of tin plated copper, and this has low melting point, and this wire has a much greater resistance than the rest of the electric wiring in the house. So what is happening here? More amount of heat is produced. So due to this, if the current in the electric wiring suddenly increases too much, then the fuse wire gets heated, it melts and it breaks the circuit, which means that the current flowing in the household circuit will be stopped. Therefore, it can prevent fire in the houses and also the damage of various electrical appliances like refrigerator, fan, tube lights, TVs, etc. So when a fuse gets blown or breaks, a new fuse has to be fitted in its place in order to restore the electricity supply in the household circuit. Now what is the learning? That a thick wire should not be used as a fuse wire, because thick wire will be having low resistance, so it will not heat much to its so that its melting point is reached, and therefore it will allow the large current to pass through it. This is how a fuse look like, which are used in our switchboards. In our next lecture, we will be discussing about application of heating effect of electric current. Thank you.